this is going to work. Okay, so it is May 11th. And we're doing a little more work with integration by parts. This is still section 7.2. More integration by parts. And maybe we'll stop talking. That's a good plan. More integration by parts. We did a cyclical integral yesterday, but I want to take a look at one that will be a little bit more involved just because we'll have to do like U substitutions with the integrals and chain rule with the derivatives. Let's take a look at one more cyclical integral and then we'll do a few other variations. So, cyclical integrals. And again, what is the kind of clue that we're going to have a cyclical integral? T and E. If we have something trig and exponential at the same time, it will be cyclical. And remember, we'll have to do that trick of, when we're done, use a little bit of algebra to move something from one side to the other side. Let's take a look at integrating e to the negative 2x times the cosine of 3x dx. Let's go over a little more. We're going to integrate e to the negative 2x cosine 3x dx. It is obviously cyclical because I have t and I have e. I have something trig, I have something exponential. So with that in mind, what's u going to be? Cosine 3x. And dv? E to the negative 2x. And for good measure, I should just say a dx at the end. Be careful now, and be careful for two reasons. What is the derivative of the cosine of 3x? We'll call on Liam for the next one. Negative 3, I like that you said negative because we're doing derivatives now. Derivative of cosine is a negative. And I also like that you had that 3 in there because what rule are you using? Of course you are. This should be negative 3 sine 3x. Liam, we need a U substitution to do the integral, but can you just kind of tell me what the answer will be? It will be. Do you get where that negative 1/2 is coming from? I'm not actually writing out my whole... Okay, so I'm not going to use a U substitution because I already have a U there, but I can do like a double U substitution. We talked about those last time. We can say W equals negative 2x. So dW is going to be negative 2 dx. So to integrate e to the negative 2x dx, right, I'm just kind of skipping because I know it's going to be 1 over the thing inside. But just to finish it off, negative 2 in, negative 1/2 out, negative 1/2 times the integral of e to the u du is negative 1/2 e to the negative 2x, which is what I want. When they're what I would consider easy enough U substitutions, I think I may skip them just realizing it's going to be 1 over the constant thing up front. Okay, so u times v minus the integral of v du. I'm going to continue that, rewrite the left side thing, because eventually we'll have to do a little bit of algebra here. Integral of e to the negative 2x times the cosine of 3x dx should equal. Sam, what's the first part going to be?
Negative 1/2 e to the negative 2x cosine 3x.
Sure. It's just going to be our u times v. Minus the integral. Now, when we actually multiply those together, will it actually stay minus? I'm seeing some shaking heads. No, it won't stay minus? Okay. Should I continue with a minus? Okay. How do I want to do this? Oh, forget it. Let's just go. What was that? Okay. Let me leave the minus. When I multiply, I would get a positive 3/2. I'll move it out in a moment, but it will keep it negative. I guess I'll just leave the 3/2 inside for the moment. Then I'm going to say e to the negative 2x times the sine of 3x dx. We will get negative 1/2 e to the negative 2x. I'm really just going to pull out the constant at this point. Cosine 3x minus 3/2 times the integral of e to the negative 2x sine 3x dx. I would like you to deal with the next round of this thing. Do your integration by parts on e to the negative 2x sine 3x. Leave that 3/2 out front and make sure you're putting parentheses around your answer, because when we're done, we'll need to go and distribute the negative 3/2. But take a moment and do integration by parts on the e to the negative 2x sine 3x piece. See what you can do. Bless you. No promises that I'm right. But I might be. I'm seeing a few people nodding. So hopefully you did something like saying u is the sine of 3x, so dv is e to the negative 2x. The derivative of sine 3x is 3 cosine 3x. The integral of e to the negative 2x is negative 1/2 e to the negative 2x. Here's my u times v, minus, sorry, it gets a little messy at the end, minus the integral of v du. We can pull out this negative 3/2, make it a positive 3/2 up front, but I tried to combine two steps in one. Maybe I shouldn't have done that. But at this point, I went and distributed that negative 3/2 that was up front to give me a positive 3/4 before my e to the negative 2x sine 3x. And then to give me a, okay, so this is positive, I'm distributing a negative. I'm going to get a negative over here, negative 9/4 times the integral of e to the negative 2x cosine 3x dx. It's the same process. It just gets a little messier when we have the U substitutions in the chain rule because we've got those constants we have to deal with. So now what? Sarah?
You can subtract the last part.
I'm not going to do that. I'm not going to subtract 9/4 times the integral. You mean add, right?
Yeah.
Let's add it instead. But that's exactly what we're going to do. I'm going to add 9/4 times the integral of e to the negative 2x cosine 3x dx to both sides. And really, truly, although this looks really weird, we are just going to combine like terms here. On the right side, I have one of those integrals plus 9/4 of those integrals. What's one of something plus 9/4 of that thing? 13/4 of that thing. So I'm going to get 13/4. I think I need to move up a little bit. 13/4 times the integral of e to the negative 2x cosine 3x dx is going to equal negative 1/2 e to the negative 2x cosine 3x plus 3/4 e to the negative 2x sine 3x. I'll deal with the constant once I'm truly done with everything. So now what? Liam? Yeah, what's a nicer way to talk about that? You're right, but multiply by 4/3. Or 4/13, right, because there was a 1 over there. You are going to get the integral of e to the negative 2x cosine 3x dx is going to equal. Let me just write it out, then I'll simplify later. Oh, you know what? I don't want to do that. I just want to simplify as we go. Before the negative 2, we can just say that's a negative 2 up top over 13. So negative 2/13 e to the negative 2x cosine 3x plus, now what? What was that? 3/13, because the 4's are going to cancel there. We're going to get 3/13 times e to the negative 2x, sine 3x, and I'm almost done. Of course, it's time to add constant. It is. My promise for you is you will not have more than one of these on the quiz and one on the test. Because honestly, though, if you can do one, you can kind of do any of those. And I will also promise you that I will give you plenty of room. Before we go on, I know it's not the same as if we were doing this on the board, but can you see well enough with this? Can we follow? Okay. Hopefully this will work for tomorrow. I'm going to wait a moment, though. And Vicki, are you just copying, or do you have some questions? Okay. No rush. Is anyone else still copying? Okay. That's all I really want to say about cyclical integrals. And honestly, I think of all the variations, that's probably the most involved variation. Other things we're going to look at will not be quite so messy. So next, we need to look at some definite integrals. A little bit. Let's deal with some definite integrals. For example, let's take a look. Bless you. Let's take a look at the integral from 1 to e of x cubed times the natural log of x dx. Thank you. X cubed times the natural log of x dx. Let me tell you the annoying way to do this problem, and then we're going to do this in a much simpler way. The annoying way is when we do our u and dv and all that, we're going to change the limits one way in one place and another way in another place, and lots of messy things there. That's going to be a pain, and that's not how I'm going to recommend doing this. What I'm going to recommend doing is let's just completely ignore the limits of integration. Let's find our antiderivative, and when we're done with that, then we'll go back, we'll put them in, and just plug in those limits of integration to the final antiderivative. So our trick here is we are going to ignore limits of integration and just find the antiderivative. Bless you. We're going to ignore the limits of integration and just find the antiderivative. Then, when we're done, we'll plug in. We'll deal with that part together. What I would like you to take a few moments to do right now is I would like you to integrate dx times the natural log of x dx. We're just ignoring the limits of integration. Go do your LIATE, find your u, your dv, and let's get an antiderivative. So this is what I have after my first round of integration, using integration by parts. Then you have that integral to deal with, but that's just going to be some algebra to clean that up. Move the constant out front and integrate with power rule for that last piece. I think we've done much harder integrals than this one. you should be integrating 1/4 times, well, you should be finding 1/4 times the integral of x cubed dx, which should give us, okay, x to the 4th over 4, natural log of x, minus 1/4 times x to the 4th over 4, plus a constant, x to the 4th over 4, ln of x, minus 1/16 x to the 4th, plus our c value for the antiderivative. Any issues with getting to there? Go.
Why comes the first part of it?
Because we can't necessarily say whatever is in front is going to be the u, whatever is at the end is the dv. That's the whole point of that LIATE thing. I have something logarithmic, that's my natural log of x. I have something algebraic, that's the x cubed. My first check mark was above the L, that's going to be my u. Because the issue is, if I make u x cubed and dv the natural log of x, you don't know the integral of the natural log of x. Well, other than how we derived it last time.
Well, is that why we started at the bottom of the x to the 4?
Okay, first of all, are you okay with how I chose my u?
Yeah.
Okay, so now, my formula says, let's do the product of the forward diagonal. Let's do u times v. No. Formula is u times v minus the integral of v du. That's important. Does that make sense? Any other issues so far? Do I actually need the plus c? No. Why can I ignore it here? Because we're about to do the definite integral thing, plug in our limits of integration. Yeah, we should ignore the c's at this point moving forward. Now returning to the definite integral. The integral from 1 to e of x cubed times the natural log of x dx is just going to equal x to the 4th over 4 times the natural log of x minus 1/16 times x to the 4th, evaluated from 1 up to e. You are going to plug in e, I'd put it in a big set of parentheses, minus plug in 1, again in a big set of parentheses, and then do some simplifying. Some nice things will happen, some not great things. You might have some e's left in the answer, that's okay. See if you can finish this off in a moment. And of course, remember the whole point of this is we're trying to find the area under this x cubed natural log of x thing. And our answer will be that signed area. Of course, I will expect you to know what the natural log of e is and what the natural log of 1 is. Those are kind of important. Sarah Slater, what's the natural log of e? This piece over here is just 1, so we're just going to get, I'll write it like this, 1/4 e to the 4th times 1, minus that 1/16 e to the 4th. I'm just going to kind of leave that for right now. I'll do more in a moment. Minus, McKenna, what's the natural log of 1? 0. So this piece over here is going to become 0. I'm just going to say minus 0. Distributing the negative will then at the end give me a plus 1/16 times 1/4, just 1/16 over there. I don't really want to leave it like this. I want to do a little more. Sarah? Yeah. So we can turn this into 4/16 e to the 4th minus 1/16 e to the 4th plus 1/16, and then we can say we're going to have 3/16 e to the 4th plus 1/16. I'm fine with that. I'm also fine with 3 e to the 4th plus 1 over 16. Just don't leave things that could be combined as like terms. I don't think these definite integrals are terrible. Ignore that part. Find the antiderivative and plug in. If you have a definite integral with a cyclical one, which I think you'll see in the homework, well, just ignore the numbers. Deal with the integrating the cyclical thing, and when you're done, plug the numbers in. There's one more variation we need to look at. This is my favorite variation. We'll give this a name in a little bit, but I would like to deal with integrating. Oh, you can't see that. I want to deal with x to the fourth times e to the 3x dx. I want to integrate x to the fourth times e to the 3x dx. Does anyone besides me think this is going to be a little annoying? And why? Liam. You're going to do integration by parts, and you're going to get an integral no longer with an x to the fourth, but with an x to the third. And then x squared, and x, and a constant. And I was actually really nice by giving you x to the fourth and not making it x to the 10th, or something like that. There is a fun little shortcut, though, that we can use. And we are going to call this the chart method. Your book calls it a tabular method. When they say in the directions, use the tabular method, use the chart method. It's just another name for this thing. This method is going to be used when we have to do repeated integration by parts, especially when it's repeated over and over and over again. For repeated integration by parts. And to be a little more specific, this is when we have things in the form a and t, or a and e, when the powers are high. If the power is 2, well, yeah, you'll have to do repeated integration by parts, but we did some of those last time. It took a little bit of work, but it ended quickly enough. Powers of 3, 4, 5, higher powers, we're going to want to use the shortcut method. I am going to make a chart with 3 columns. The first column I am going to label sine. The second column I'm going to label u. The third column I'm going to label dv. L-I-A-T-E, I have A, I have E. If we were doing normal integration by parts, what would you make your first u? The x to the fourth. Because that's the A piece, that's the algebraic part. And our first dv, e to the 3x. And then you know that we would calculate the du, the derivative of u, and then the v, the integral of e to the 3x. But here's the deal. What becomes the integral of this, no, let me try again. What becomes our du, the derivative of this thing, and what becomes the v, the integral of this thing, will in our next round of integration by parts be that integration by parts is u and dv. What I am going to, and we're going to keep doing things like that. What I am going to do is I am going to go down, and in each row of my u column, I am going to find derivatives. As we go down with our u's, we are going to find derivatives. As I go down in my dv column, I am going to find antiderivatives. Because the next line of integration by parts involves me using the u and the v, but then those will become the u and the dv of the next problem, and we're just going to sort of keep going through this process. This chart will just let us simplify all that work. What is the derivative of x to the fourth? Easy. 4x cubed. What is the antiderivative of e to the 3x dx? 1/3, we're not writing it out, but we're really doing a U substitution here. I'm going to say 1/3 e to the 3x. I'm just going to keep doing this. What is the derivative of 4x cubed? What is the antiderivative of 1/3 e to the 3x? 1/9. The 1/3 was already there. Let's move another 1/3 out front and make this 1/9 e to the 3x. Guess what? I'm going to do it again. 24x. You didn't say 27, did you? Not 27, but you don't mean I should write 27. Sorry, okay. I didn't hear the 1 over part. You win. 1 over 27, e to the 3x. That's good. Do it again. Hopefully this is going to end at some point. What's the next one? What's the dv? Next. What's the derivative of 24? You can do that. 0. 81 times 3. Well, here's what you can do if you don't know that. You can write it out. It is. But if you don't know it, you can write out the multiplication problem. Because, of course, when we get to a quiz, it will be non-calculator. Write out the multiplication problem and do it. Or what? Of course. Why do I feel like I'm done? Okay, and as we continue, all the derivatives will remain 0, and somehow that's going to get multiplied by something else. There's a column that I ignored. The sign. What we are going to do is just go and... Oh, hold on a minute. Hello? That's okay. He is not. This is absence number 14. Yep. Yep, bye. Sorry. Probably shouldn't have announced that one. Don't worry. It's all good. Okay. For the sign column, what we are going to do is just alternate pluses and minuses. This comes from the fact that our integration by parts formula has that minus the integral thing. And then on the next round, we would distribute the negative, and the integral will become a plus thing. Ignore all that. Right now, I'm just going to alternate each row. We'll alternate plus, minus, plus, minus, plus, minus. Here is the fun, quick, shortcut way we are going to use this chart to get the answer. Do you agree that the first answer should just be my u times v? Here's u. If this was my first dv, what is my v? 1 below it. My first... Oh, this isn't a great one. I want to use a different color, though. Oh, the red one will work. My first term will be positive because of the sign. X to the 4th times 1/3 e to the 3x. I'm going to start writing out my answer. I am going to get 1/3 times x to the 4th e to the 3x. And I'm going to continue doing this. Use the sign that's next to the u and go diagonal down. That's like the whole diagonal thing I do when I write out my little chart anyhow to get the next term. My next term is going to be 4/9 x to the 3rd e to the 3x. Do you see where I'm getting these pieces from? Will the next one be positive or negative? Positive because of the sign over there. And I'm going to multiply. I'll do my simplifying later. But for right now, I'm going to say 12 over 27 x squared e to the 3x. I want to see if you can continue this pattern. And then when we're done, we'll just have a little bit of simplifying to do. Other than the fact that I didn't simplify, what did I do wrong? Well, not wrong, but there's still going to be a plus c. Don't forget about that. Oh, what? No, I don't know why I decided to put it up top of the 24, but it is there with the 24. Do you realize now, when I'm using this diagonal thing, why it was okay that I stopped when I got to a 0 for my derivative? Because wouldn't every other diagonal then just give you 0? Okay, we have some cleaning up to do. 1/3 x to the 4th e to the 3x, that's fine. Minus 4/9 x to the 3rd e to the 3x, that's fine. Next one is not. Okay. Okay. Yes. And that, I think, should make perfect sense because of how we got the constants from out front with our integrals. Yeah, we can divide everything by 3 here, and I think that's actually going to be all we're going to be allowed to do moving forward with all of these in this problem. So we should get 4 over 9, x squared, e to the 3x, minus 8 over 27, can't do anything more there, x e to the 3x, plus 8 over 81. Yeah, this will still be non-calculator. Those weren't too terrible to simplify. We should have our basic arithmetic skills still there. Keep working on it. This is the chart method. It took a little while to go through, but I still think this would have been much, much quicker than trying to do integration by parts again and again and again, kind of like with those nested integrals and things like that. But still involves a little bit of work and certainly a lot of keeping track of things. And unfortunately, if like this derivative is a little bit wrong, all the derivatives that follow will be wrong. But I mean, that would have happened with regular integration by parts anyhow. Once you get a piece that's not right, everything that follows from that calculation will also be wrong. This gets a little bit trickier when instead of an AE thing, it's an AT thing. When the dv is something trig, which will also have some positive and negatives factored in there in addition to the column out front. Abby.
So for the sign for these ones, do you always start with positive?
Yes. You're always going to start positive and then just alternate. I can't necessarily say that about the answer, though, because there could be some other things that factor into making your final answer positive versus negative, and that's what we're going to see right now. Let's take a look. Exactly. You'd have positives and negatives over here, and you would incorporate that sign when you do your multiplication. Let's take a look at, I had a list of things I wanted to do. Okay. Let's take a look at the integral of x to the 5th times e to the 3x dx. You know what? No, we just did 3x. We're going to make it 2x. Sorry. We don't want the same 1/3, 1/9, and so on. And what I'd like you to take a few moments to do right now is set up your chart. 3 columns, and get all the rows we're going to need. Then maybe together, we'll try to get the final answer. And while you're doing this, just so we're not scrambling at the end, homework is bookwork, but there were a bunch of even problems in there, plus I wasn't always crazy with how the answers in the back of the book looked. So I'm just going to give you answers for things so you can check your work as you go. Those of you who will not be here because of AP exams tomorrow, what you, in theory, will need to do is go to the website, and there should, oh, that's a problem. Go to the, okay, I will finish that thought in a moment. Let me see if it's still, oh, we're still recording. We're still good. Go to the website, and there should be a link on the calendar under tomorrow's date with, in theory, a link to the video from tomorrow, in theory. And also in theory with sound. If anyone talks to the people who weren't here today, let them know that in theory there will be a link on the website for the notes from today. Yeah, no, those are just answers because the form of their answer might be a little different, and there was something else. There are some evens as well. If you still feel like you need to actually write out your U substitutions to do the integrals, please do that. I'd much rather you do a little more work and get it right than just sort of hope for the best and have things wrong. Every year I'm used to some people doing that last column with chain rule, which is not good because that's a derivative thing. I'm sorry. I'm going to stop you guys. There was something specific I wanted you to see. Yeah, and not even that. I wanted you to see a trig thing with the alternating signs in the other column. I'm really sorry. I want to take a look at something else. Sorry. I know. You can still finish that for your notes to make your notes complete, because that would bother me if I was like a student with an incomplete example. But how about I make the power a little lower? I'll make it x to the third, and I want to do the sine of 5x. I know, but I really want you to see what happens when the positive and negatives alternate, affecting with the positives and negatives out front. I'm sorry. I know. Wine. We're good at that. You want to just do it together? No. Okay. Well then. See? Yeah, these you can't really do in your head. And I appreciate you writing things down. Okay, let's not give him a hard time for this. Keep working. And maybe don't put it all together yet. Let's do the putting it together part as a group, because I want to make sure things worked out. You have this much? Did the easy part. What's the integral of the sine of 5x? 50-50 chance with this one. Okay, so first of all, we need a 1/5. Are we doing cosine or negative cosine? We are doing integrals here. The integral of sine is negative cosine. Yes, it should be negative. Next, I'm going to get a 1/25, either positive or negative. Negative. So the integral of cosine is positive sine, but there was already a negative out front, so we're going to make it negative 1/25 sine 5x. What's the next number? 1 over 125. Positive or negative here? Positive, and we want a cosine this time. And finally? Good. If you need to make that little chart that we've done before with sine, cosine, negative, absolutely do that. And realize that we're going up that chart this time because we're doing integrals. Okay, I'm going to do my connect this thing. I am going to get not positive for my first term. Sure, this is positive, but this sign over here will make that entire term something negative. I'm going to get negative 1/5 x cubed cosine 5x. Plus or minus for your next term? Plus. I have a minus, but I have another negative as well. You're going to get plus 3/25 x squared sine 5x. Next. Plus 6 x over 125. I'll simplify in a moment. Cosine 5x minus 6 over 625 sine 5x plus your constant. Then just do a little bit of simplifying and we'll be set. Can you do anything with 3/25? No, you can't. 3/24, sure, but not 3/25. So 6 over 125. Actually, maybe. Yeah, we can. Wait, hold on. Divide by either 2, which is impossible, or divide by actually, I don't think we can do any of these. Well, that's nice and convenient. So I really could have just circled the previous answer instead of rewriting it. But I'm going to keep going. I know. Life is tough. It's also good for you to get practice writing things. That's all I want to teach you with integration by parts. We will spend time on Monday practicing this. We have one final topic we're going to do, and it's actually a topic you already know, L'Hopital's rule. However, we only learned 2 indeterminate forms, 0 over 0 and infinity over infinity. There are 5 more that are variations of that, which are not as straightforward as just derivative of this over derivative of that. We will deal with all of those tomorrow. And then actually, I think the day that we practice integration by parts, I may throw some of that L'Hopital's rule stuff in there as well. We will have a quiz on integration by parts Tuesday of next week. I know some of you won't be here Monday. We will have a quiz on integration by parts on Tuesday, because there's a field trip on Monday, marine biology. Test is next Friday. I am not going to have the review packets until Monday. I will see what happens tonight. I'm not going to make any promises. In the meantime, I'm going to stop recording. They don't need to hear all of